Welcome to the lecture series on soft computing in computer science. In this lecture, I wish to introduce a new soft computing paradigm called fuzzy logic. To begin with, let us first understand what is fuzzy, and based on the concept of fuzzy, I will introduce the topic fuzzy sets and its operation. What is fuzzy? When you want to deal with fuzzy, you must remember the key point related to the fuzzy. You know, everything around us is treated as information. This information can be divided into two kinds, one is measurement based, another one is perception based. If you take the example for measurement based information, it is 100 degrees Celsius, EVA is 18. See, some numerical values are involved in a measurement based information. But when you come to perception based information, again there are two kinds. One is Boolean based information, another one is linguistic based information. When I want to say it is 100 degrees Celsius, rather than if I say it is hot, I am saying that the information, that the quantity of water, the items or whatever it is placed, it is hot. And Eva is a girl, rather than telling her age as a measurement, we are telling her Eva is a boy or girl, like that we are telling Eva is a girl. On the other hand, when it is going for linguistic based information, rather telling only mere it is hot, how hot it is very hot. Eva is a girl, but whether she is a young girl or a middle aged or a old. So in that aspects, here if we have mentioned the word as young, Eva is a young girl. So on the whole, if you see that information can be given to anyone, or information can be passed from one person to another person via these kind of strategies. One is measurement based information, another one is perception based information, and on the perception based information we have Boolean as well as linguistic based information. Of course, this perception based information is the one which we are using in our common day to day life. When it is come to Boolean based information, this Boolean based information tells only the metric of the information, or it tells only about what actually it is, rather than in a linguistic based information it tries to include the subjective information. For one person, if you give a cup of coffee, it may be hot. For some other person, it may not be that much hot. For one person, Eva is looking like a young girl. For some other persons, Eva may not be a young girl, she may be a small girl, maybe within age 1 to 5, a baby, or maybe a middle aged girl, like that. So the perception differs person to person. So if the perception differs from person to person, then it is a linguistic based information. If the person is unique among all the persons, then it is Boolean based information. Now we are going to deal with this linguistic based information. So this linguistic based information, we are not giving any guaranteed value for the word very hot, for the word young girl. In that situation, this kind of information is called fuzzy. So if you look at the dictionary, the meaning for the word fuzzy, you may see that the word fuzzy is unclear, uncertain, vague and confused. So these are all the synonymical terms for the word fuzzy. So fuzzy is not a technique, but it is a literal English word, carries these kind of meaning. Of course, if I say very hot, I am not sure, I am not very clear how much hot it is. And if I am saying that Eva is a young girl, I get confused. Young means what? Whether the age is between 15 to 25 or the age is between 5 to 15. So I cannot give any guarantee the ages. So someone young means 5 to 15, someone young means 15 to 25, like that. So in that aspects, this holistic based or this universal language based information, that is linguistic based information, is the words that we are commonly using in our day to day life. And if you look at that, these words are not clearly defined. Why? Because it has some fuzzy in that. So when you want to deal such kind of information using computer, or who is very good at processing this kind of information or bringing some conclusion over such kind of information, who is very good? If I could say that, humans. Why? Humans are very good at perceiving this information and processing this kind of information, because humans are having common sense to reason about such kind of vague and uncertain information. Why? Because a human is having this ability, that is common sense, to process the information, because the human is having a wonderful organ, it is a God's creation, human brain, and that human brain has the capacity to reason any vague assertion. If the information is very vague, and it is the capacity of our brain to do some analytics over that vague information and come to a definite conclusion. And also it can claim whatever may be the kind of information that involves uncertainty. So that is the wonderful thing that every human is having. So to process any linguistic based information, person to person, it is very easier. If any one person asks you how far a place from here, if the person is saying that, instead of saying 10 kilometer from here, instead of he is saying it is not very far, it is very nearby only. See, it is 10 kilometer distance, that is the one information given by one human to another human, and one human is saying that it is not very far, it is very nearby. How can I quantify that information? Very far, not very far, not so far, it is nearby. How can I quantify this kind of information? When this kind of information is fed into computer, a person can process. Say for example, if you say this kind of information, it is not very far, it is very nearby. One person assume that, oh, it is 3 kilometer. One person may assume that no, it is 5 kilometer. One person maybe it is 1 kilometer. But it is person to person varies, but even then that information can be easily understood when this information is communicated by one person to another person. But when this kind of information is fed into computer, how this kind of information is processed? How human is processing? Because human is having some common sense, that common sense will work out and will try to quantify the information very far, nearby, maybe within 3 to 5 kilometer, he may treat that as a very far as well as very nearby, like that. Why that common sense is there with the human being? Because of the wonderful organ, human brain. Now our objective and our goal is, why not computer? Thinking about how to make computer to process such kind of information. If a human is doing that task, why not computer? See, the objective of our soft computing course is to make any computer or any machine to behave like a human being, to process the information and to work as an autonomous system. So our goal is always, whatever the task that has been carried out by a human being, why not computer? Why not computer? The answer is, a computer can manipulate only precise facts, because computer is a machine that can do mostly the calibration in a very faster manner. So that is the major strength of a machine. When you compare a machine and a human being, a machine, can I take an example as a computer can process numerical values in a very speedy manner when you do. So when I ask a person to calculate the addition of two bigger numbers, he may take some amount of time, but on the same time when that two numbers is fed into computer, the computer will do that calculation very fastly. So what is the major strength of a machine? Speed is the major strength of the machine. What is the major strength of a human being? Looking at every information and through a common sense and reason about the fact. That is very lagging in the computer. And what is this objective of this soft computing? How to make this computer to behave like a human being so that the computer can also process this linguistic kind of information. Because most of our daily life we are using these kind of fuzzy words. So I want to do some sort of natural language processing using these kind of linguistic based information. To do so, I have to make computer to reason about the information provided. To make the computer to reason about the information provided, I need three ideas. One is logic, another one is set, and the third one is inference. Why logic is needed? Logic is needed to describe any unclear statement. On what logic you are saying that this very far away or very nearby into a accountable value. So we need logic, we need certain logic, and we need to calibrate the vagueness, we need to give some values to very far away, nearby. Universally we need to give some values to it, because one person may take it is 3 kilometer, one person may take it is a 5 kilometer. So universally I have to take this kind of stuff, right. So I need to calibrate the vague value associated with the information, for which I need set. And the last but most important one is inference. Okay, now I am able to describe the unclear statement. After describing the unclear statement, now I can come to a particular value based on the vagueness associated with the information. Now what kind of decision I want to take, I wish to take using the computer. So those kind of steps can be carried out with the help of a idea called inference. So these three are very important when you wish to make a computer to be a fuzzy enabled system, so that any linguistic based information or any uncertain data, if you fed it, the computer can apply these kind of logic, set and inference and work as a human being by means of common sense. See? So this is what we are going to dealt in this second phase of soft computing, fuzzy logic. So to begin with, let me introduce the fuzzy logic. So what is fuzzy logic? Fuzzy logic is defined as the organized method of dealing with imprecise data. You are provided with imprecise data. What imprecise data you are provided with? You are provided with very far away. No, it is very nearby. So that imprecise data has to be quantified by the computer. So in order to quantify by the computer, we need an organized procedure, we need an organized method. There comes the idea of fuzzy logic. So this concept of fuzzy logic for first introduced by Lofty Jada, who is treated as a father of fuzzy logic, and he is a professor in the University of California, and he introduced this concept in the year 1965. What this fuzzy logic will do? This fuzzy logic allows the computer to emulate human reasoning process. Yes, of course. How a human is quantifying this uncertain information? Because the human is having some common sense. Based on the common sense behavior of human brain, the human is taking some decision over some uncertain information. So the fuzzy logic should allow computers to imitate the human reasoning process. Why? In order to quantify imprecise information, based on the quantified value we need to make decisions. The data may be of vague and incomplete. So that is the idea. So overall, fuzzy logic tries to mimic, imitate and try to portray how a human is making decisions in a, even with the support of incomplete data. So that is the idea of fuzzy logic. When you dealt with fuzzy logic, everyone should remember about a idea called bivalent logic. What is bivalent logic? It is generally called as logic. You all studied about logic gates, or you all heard about logic gates. It is the one which is accepting 0 and it dealt with only binary values. So what is bivalent? By-value, that is a 2 value at a time. What are those 2 values? 0 or 1. When you want to make a decision whether, after hearing that, the word nearby or very far away, your brain will presume that the far away as well as nearby to be a quantifiable information, and based on that quantifiable information you might decide whether we have to go to that place or not, whether we can go to that place by bike or by car or by some other mode of transport or not. So in order to make a sharp decision at any instant, so far before 1965 we have used only the bivalent logic, that is 2 valued logic. There comes the idea of multi-valued logic. Instead of having only 2 values, we have many values, infinite values. Let us take an example. And this idea of fuzzy logic make the computer to decide as that of a human being by using degrees of values, not a single value, uses a degrees of value to make a decision. So when you want to apply fuzzy logic or when you want to design a model based on fuzzy logic, the fuzzy logic is very well enough to solve any complex and non-linear problems only by way of linguistically rather than mathematically. Yes, of course. See, Boolean logic. Here you may have a sharp boundary. So one side is white, another side is black. But here if you guess that the 0 is going along and then it was transferred to 1. So there is a smooth transition between the day side to night side, that is white side to black side. So this is the multi-valid logic. Let me come to a next idea after the logic, set. While understanding set, we need to study about the classical set, that is set theory idea that is prevalent in mathematics. Because the concept of fuzzy logic starts with the concept of fuzzy set theory. This fuzzy set theory again, it is going to be a contradictory concept. Please remember, it is a contradictory concept with respect to classical set theory. Because in classical set theory, we have a crisp boundary, either 0 or 1. Say for example, when you toss a coin, right, either it is head or tail. So the set, if you want to put, either it will be 0 or 1. But when you want to apply fuzzy for a kind of problem, then you should accept that that kind of problem should involve a unambiguous boundary or a clear boundary. In that is the case, classical set theory is okay, right. Let us take an example. See, I want to classify some set of person whose height is greater than 6. So how can I mathematically model that value? So to mathematically model that value, I can say that height such that height greater than 6. So that is A is equal to set of all persons whose height is greater than 6. So here my boundary is very clear, my boundary is very much unambiguous, right. So what is that my boundary? My boundary is value 6. Below 6 all are short, that is 0. Above 6 all are height, that is 1. So I cannot have any value in between that. What about a person which is having 5.9? If it is classical theory, he is treated as short. But we may not say, and we should not say this value is short. We should associate it with some degrees of values, right. So what is the problem with the classical set theory? So as I said mentioned, what is the, how can I treat a person whose height is 6.001? How can I treat a person whose height is 5.999? Because these two heights are treated at differently. This person is smaller, not taller person. This is treated as a tall person because a classical set has a sharp transition between one thing to include and one thing to exclude. Inclusion means that is belong to a set, exclusion means that is not belong to a set. So to be precisely speaking, in contrast to classical set, this fuzzy set is a set without any crisp boundary and it always shows a smooth transition, not a sharp transition. So the inclusion of a particular value into a set and the exclusion of a particular value out of from the set is taken only by a smooth transition by means of degrees of values, not only with the actual value. So what is the problem with the classical set? These kind of ambiguous and uncertain value. How can I quantify this? So this is the major problem with the classical set. Of course, for certain kind of problems, this classical set is very fine, but this kind of linguistic based information, classical set won't be a good idea to proceed with. You have to think about the alternate way or a contrast way of classical set theory. There comes a fuzzy set. So what is this fuzzy set is doing? This fuzzy set generalizes the classical set theory. Yeah, yes, of course, it is tries to generalize. How? To allow partial membership with a smooth boundary. Yes, that smooth transition that a fuzzy set is applying while quantifying the uncertain information is characterized by a function called membership function. That is decided, that is chosen based on the characteristics of the information or based on the characteristics of the linguistic expressions. That means if I say the water is hot or the temperature is high, I want to quantify how much the water is hot, how much the temperature is high. So simply by looking at the linguistic expression, the fuzzy set can able to quantify that value by means of a smooth transition by means of using membership function. So the degrees of membership is treated as a number between 0 and 1. So here there is no 0, then sharp transition 1, here 0 and 0 is going to a smooth transition to 1. So that is the fundamental principle and idea behind the fuzzy set. And this fuzzy set is mathematically defined as a fuzzy set A is expressed as a set of ordered pairs. What is the ordered pairs? One is x, another is mu a of x. What is this mu of x? This mu of x is the membership function. A fuzzy set is totally characterized by a membership function. If it, say for example, A is a set of tall person, right? So A is represented as A equal to x such that x greater than 6. This is classical set theory. If I want to apply fuzzy set theory, then A equal to x comma mu A of x. So I have to represent mu A of x. I have to define what is mu A of x. First I have to attach mu A of x, then I have to define what is that mu A of x. Then I can say that I have clearly defined what is fuzzy set. So this is the idea behind the fuzzy set. Again, the difference between classical and fuzzy set. In classical set or crisp set, I have a sharp boundary, but whereas in fuzzy set, I have a smooth transition from the inclusion to exclusion. Right. If you take 5.5 feet 10 inch height, maybe he didn't belong to the tallest category, so he may be belong to a category. But when you take, he may belong to the tall category, but that value is between this. So here this you may treat that as a degrees of values like that. So fuzzy set with a discrete non-ordered universe. Let us take an example. Let X be a set consisting of some regions, Chennai, Bangalore, Mumbai. That may be some set of cities one may choose to live in. Now, if I want to define a fuzzy set as a C to decide desirable city to live in, I can say that for most of the people Chennai it is 0.9, Bangalore 0.8 and Mumbai 0.6. It means that if you want to characterize the fuzzy set, out of the 100%, 90% are showing interest in to be reside in Chennai or for want of job in Chennai, and 80% want of job in Bangalore and 60% want of job in Mumbai. So it is clearly found that the universe of discourse X contains any three big cities of India which is non-ordered discrete value, and membership grades are subjective in nature. So this subjective is very important. When you dealt with the probability as well as the set theory, it is an objective phenomena and the values are universal, whereas this fuzzy set is a subjective phenomena and the values are three different values and it refers to the one's preference. It is subjective in nature. Fuzzy set with a discrete ordered set of universe. Here if you can say that, see, the values are, for each value the values are between 0 and 1. So when you find a fuzzy set with a discrete value or discrete non-ordered universe of set of values, whatever it is, when you want to apply fuzzy, each fuzzy value should be applied with yes degrees of values. So the universe of discourse contains ordered set of values and associated with the ordered set of values should be associated with their membership grades. So this is what the fuzzy set, and when you want to dealt with a continuous universe of discourse, and this continuous universe of discourse should be characterized by a membership function. Let us take an example, fuzzy set A about 50 years old. So it is a membership function, see, exponential membership function. So these kind of characterization is very essential when you want to define a fuzzy set. So addition to the exact value x, you should be characterizing mu a of x. So this is what the fuzzy set. So again I am talking about the difference between fuzzy versus probability. So in general, construction of fuzzy set depends on two things. One is identification of suitable universe of discourse, another one is specification of an appropriate membership function. But subjectivity and non-randomness are the primary differences between fuzzy and probability theory. So with this I close the first part of the session for fuzzy set and operation. In the next session we will be in detail seeing about the various operations of fuzzy, union, intersection and other related stuff. So keep watching.